Good evening, young people. Today we're going to be talking about mole calculations. Now, I explained to you today, you actually know how to do these. You know how the math works. The problem becomes in the understanding of the concept of a mole and the relationships that are involved there. So today we're going to be talking about two relationships. We're going to add two more a little bit later in the week, and then we'll go from there, okay? So, any method. So if I want to know how many cupcakes there would be in 4.34 dozen. You know the answer to this question already. You don't have to do much work. You know what to do, but I want to break it down into steps so that we can understand what we're trying to do. I'm moving my face a little bit. Sorry about that. So, I know that I'm starting with 4.34 dozen. That's the only number that I'm given in the problem. What am I looking for? I'm looking for the number of cupcakes that are in that. I then draw my conversion bar, which is this thing that some people call it a picket fence, some people call it a conversion bar, some people call it the football down. It doesn't really matter. You know what it looks like. So I know that I need to get rid of dozen, and there's 1 dozen, okay? And there are 12 cupcakes in every 1 dozen cupcakes. So when I do my multiplication, dozen cancels out because one's on the top, one's on the bottom. All that cancels out, which means I'm left with units of cupcakes here. You can see my units right here, cupcakes, which is the unit that I want. That's kind of key. I do my multiplication, 4.34 times 12 divided by 1, and I get an answer of 52.1 cupcakes. Now you're going to say, Ms. Rains, you can't have 0.1 a cupcake. No, you can't, but officially I have 3 significant figures over here, so I have to have 3 significant figures over here. So in reality, I would need 52 and a little bit more of a cupcake. So maybe a mini cupcake would make for that. So let's try another one. So Mrs. Rains needs to buy 226 mini cookies. She can find them in packages of 36 cookies. How many packages does she need to buy? This problem should look familiar to you because we did this for warm-up on last Friday. So what are we looking at here? Well, I know that I have 226 cookies. That's what I'm given. I know that. Now I wanted to do this problem because it doesn't have a regular relationship like the other one that we just did. So I wanted to show you that you did the math on your own. So we know we have 226 cookies. I know that I need to figure out how many packages that she needs to buy, that I need to buy. I do my conversion bars. What goes on the bottom? Well, the unit that goes on the bottom is the unit I'm trying to get rid of. The unit I'm trying to get rid of is this guy right here, cookies. So I'm going to put cookies on the bottom because that's what I want to get rid of. So what I'm going to put on the top, the one that I'm trying to get, which is packages. There's my packages. Now what numbers go with that? Well, we see in the problem, in a package, there are 36 cookies. So for every 36 cookies, that's 1 package. 1 package contains 36 cookies. See how that works? So cookies cancel out because I designed it like that. And then I do 226 times 1 divided by 36, and I get 6.28 packages. It's actually 6.2777777, but remember, I have 3 significant digits over here, so I want 3 significant digits over here. Okay? So what are we doing here, and how are we getting this? And so let's look at some mole relationships. So I call this the mole heart. And the mole heart, everything is equal to 1 mole. So representative particles, we talked about this on Friday. Representative particles are formula units, molecules, or atoms. And so we know that there are 6.02 times 10 to the 23 representative particles for every 1 mole. Well, the other relationship that we started to develop, and we did this today, is grams. This idea that 1 mole can equal a number of grams of a substance. So we know that the atomic mass is going to be used. So we're going to go to the periodic table. We're going to work through this atomic mass. We're going to count atoms. Then we're going to multiply that number of atoms by the mass from the periodic table. We're going to add all that up, and we're going to use it in units of grams instead of atomic mass units. So instead of finding the formula mass in AMU, we're going to find the molar mass, which is the same number in grams. And we have to use the periodic table for this. You cannot do these problems without the periodic table. The periodic table is your very good friend. Now, there are 2 other relationships, and you can see up here that I have some empty spots over here that you noticed from your warm-up, but don't worry about those today. We are not going to worry about those today. We are only going to worry about representative particles and grams today. So let's do a problem. So actually, we're going to talk about the methodology. So write the given quantity and unit on the left. So that's what we start with. If you remember the two problems that we did earlier, that's exactly how we started it. We wrote what we were given and the unit that we were given on the left-hand side. Then on the right-hand side, we wrote an equal sign, some space, and then the unit we were trying to find. We did that both times. Then number three is the most complicated of the steps, because number 3 is where we get to the nitty-gritty, where we get to the relationship. So the first thing we do is we draw our conversion bar, our picket fence, or touchdown thing. I don't care what you call it. It just looks like that. So that's what you need, okay? Then we write the given unit on the bottom every single time. We write the finding unit on the top. So given unit on the bottom, finding unit on the top. Why do we do that? Because we want to cancel out the given unit and we want to get the finding unit. So we need to make sure that we put them in the right place. And step C is the hardest step here. Step C is where you have to determine the relationship. And we have one of two right now that we can work with. We can either work with particles and moles, or we can work with mass and moles. So those are the two relationships that we have going on right now. And then finally, after you do the hardest part, which is see and figure out what numbers go in the conversion bar, you then calculate. It becomes a plug and chug. The top number times the top number divided by the bottom number. The number you're given times the top number divided by the bottom number. And then you have to use correct sig figs and use the proper unit. But if you did step 2, unit becomes no problem. Okay? So let's try. How many atoms of lithium are in 3.50 moles of lithium? So what are we given? We're given 3.50 moles, so very good. We write 3.50 moles of lithium, and we probably should put lithium here. I need to correct that in my slideshow here. Okay, what am I looking for? I'm looking for atoms of lithium. Yep, of course. So I know I need to draw my conversion bar. There it is. So now I need to figure out where stuff goes. I don't worry about the numbers. You notice in that last problem that I didn't put any numbers in until the end. I didn't put any numbers in the conversion bar until I figured out which unit went where. And it's pretty easy to figure out. I want moles to go away. So if moles are on top, I have to put moles in the bottom. There they are. Okay, so what has to go on the top? And the answer is the finding unit. The finding unit is atoms, so I have to put atoms on the top. Now I have to go back to my mole heart. Okay, what relationship am I talking about? I'm talking about atoms and moles. Atoms are representative particles. What number always goes with particles? That's right. Oh, I'm sorry. What number always goes with mole? 1. What number always goes with particles? 6.02 times 10 to the 23rd. I need to flip those around in my cast there. Okay. So moles are going to cancel out by design. I wanted them to cancel out. I made sure that they canceled out, and now it's just a problem. 3.50 times 6.02 times 10 to the 23rd. Make sure you put that in your calculator right. If you don't know how, ask. I will help you with that one time at least, okay? Divided by 1, and I get an answer of 2.11 times 10 to the 24th atoms of lithium. Pretty simple. Let's try another one. Okay, so here we go. How many moles of lithium are in 1.58 times 10 to the 24th atoms of lithium? What are we given? Yeah, 1.58 times 10 to the 24th. Atoms of lithium. That is what we're given. What are we trying to find? Okay, moles of lithium. Notice how I put it down here because I'm running out of room in my space. So I've put it right here because I'm running out of room in my main line, and that's okay as long as I know that this is my given. Notice I wrote it on the right anyway. Okay, so now I draw my conversion bars. There they are. Okay, what unit's going to go on the bottom? Yeah, my given unit right here, atoms, is going to have to go on the bottom. There we go. It's going to go on the top. Moles is going to go on the top. So what number always goes with moles? Well, we'll think about that in just a second. What number always goes with atoms? What number always goes with particles? Yeah, 6.02 times 10 to the 23rd. And what number always goes with moles? 1. So now it's 1.58 times 10 to the 24th times 1. I'm sorry, atoms cancel out. There you go. And then we have 1.58 times 10 to the 24th times 1. Divided by 6.02 times 10 to the 23rd. This is when it just becomes a multiplication and division problem. So we get an answer. You notice I did this, right? 1.58 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. And we get an answer of 2.62 moles. So that's going from moles to particles and particles to moles. Pretty simple, right? So let's try grams. So molar mass, and I don't want you to be confused by this. Molar mass is simply the formula mass, but it's in unit of grams instead of AMU. We figured out a long time ago, somebody figured out a long time ago that we could take this formula mass that we calculated using these numbers, and if we just put it in units of grams, that was the same as the molar mass, the mass of 1 mole. And so that's where this comes from. People used to call it gram formula mass, gram molecular mass, gram atomic mass, but it's the same thing. It's molar mass, the mass of 1 mole. So converting moles to grams, how do we do that? Well, how many grams of lithium are in 3.50 moles of lithium? Well, what are we given? Yeah, we're given 3.50 moles. So there we go. 3.50 moles of lithium is what we're given. I don't know why the bars came up so soon. And then we write down, oh, some things are messed up on this slide. Sorry. Then we go, what are we trying to find? We're trying to find grams of lithium. Now we already have our conversion bar up. It came up a little early, but it's there. So what unit goes on the bottom? Well, guess what? Moles of lithium is what we're trying to get rid of. So we're going to put that on the bottom. So what are we going to put on the top? Yeah, what we're trying to find grams of lithium. So now we have to figure out what goes where. The number that goes with moles is always 1. What are the grams? Well, if we look on the periodic table here, this one was an older one, but we're going to use 6.94. That's from our periodic table. So our periodic table should say 6.94. So now we have 3.50. By the way, moles cancel out. 3.50 times 6.94 divided by 1, and we get an answer of 24.3 grams. And as you can see, these problems are done exactly the same way as the problems you were doing before. There's no difference in the math or the structure. The difference is right here in determining what numbers we're going to put in the center of the conversion factor. All right, so let's look at another problem. We're going the opposite way, grams to moles. So how many moles of lithium are in 18.2 grams of lithium? Okay, so what are we given? Yeah, 18.2 grams of lithium. What are we trying to find? We're trying to find moles of lithium. So now we start our conversion bar. There's the bar. What unit's going to go on the bottom? Remember, it's the unit we're trying to get rid of, and we're trying to get rid of grams. So grams go on the bottom. What's going to go on the top? Yeah, moles are going to go on the top. So there we go. So what number goes with grams? Well, this is just the atom lithium, so we're going to use this 6.94 thing. It goes with moles, 1 mole. So now it's 18.2 times 1 divided by 6.94, and we get, well, grams cancel out, sorry, and we get 2.62. Is that right? 18.2 divided by 6.94. Yep, that's right. Okay, so hopefully this will help you in completing the worksheet 1 and 2, and also looking at calculations number 6 and 7 in your writing, or what's in a chalk name, so that you can figure out that information. Also be ready to ask questions. Thank you very much.